Hey everyone, good evening. So how many of you came here for the first time attending the KubeCon? Nice, okay, same here. We are also presenting for the first time in public forum. Thanks for joining. So how many of you know what is edge compute is? Have you ever used or aware of it? Okay, couple of you, good. So thanks for joining. Today, Karthik and me, we are going to present what is building, what is edge computing, how do we actually keep an eye out on them. So my name is Naveen Kumar. I'm a solution architect, and here we have Karthik. He's a senior cloud ops engineer. We are from Kongsberg Digital. So today what we are going to look at is actually we will see what is edge compute is about and what are the key challenges that you have, how it is different from regular cloud workloads, and how do you actually keep an eye out on it, especially on metrics, as well as how do you collect logs and what kind of challenges that you get when you are collecting logs, and how do you set up security around the edge setup environments, and how do you take care of authentication and authorization, how do you segregate the data of the observability and store them, although the application by design would have some means of tenancy, but in terms of observability, how would you segregate the data and store it in different storages? And also we'll talk about some of the basic platform design. So before to this, so our company, which is Kongsberg Digital, is actually a software wing of Kongsberg Group, which is actually digital area, especially focused on taking care of industry software and digital transformation. We have deep domain expertise, especially on maritime, oil and gas, renewables, and power supply sectors. So we actually have a mission-driven innovation which is empowering industries to achieve safer, more efficient, and sustainable operations through digitalization. So today we are going to talk about one of the product which we have, which is Vessel Insight, which is our flagship edge solution, which is DNV certified. It's an industry certification, which has an edge native design. So here where we'll have an onboard computer, which is, or the edge onboard computer, which is captures, aggregates, and compresses and caches massive volumes of sensor data and system data from vessels. So we also have a global secure network which is built up on top of the internet service providers and satellite network, which will be helping us to stream the data from our edge boxes and sending it to our cloud platforms. So what is edge? So edge computing is basically a decentralized computing approach where the data processing is done closer to the source where the data has been generated. So typically, these edge boxes or edge computes are situated near to IoT device or sensors, and or the onboard systems. Some typical examples are that you have solar megawatt plant or maybe a wind farm where you want to get some of the sensor data from your edge devices and stream them, process them, and send them. So the advantage of using edge compute over the cloud compute is that it is very near to the source, so it will have a low latency network and also bandwidth efficiency. You can have cabled connection or some other means of connection where the data can be streamed really fast and gives you that reliability of transport and the data sovereignty. Sometimes you do not want to send the data to cloud, yet you want to process some data and get some insight of it. And also real-time decision. Imagine you have an autonomous car or you have a vessel where you need to steer the vessel based on the insight that you're getting from the sensors, like how fast we are going, what is the RPM of the engines, what is the fuel capacity, how much we are consuming, etc. The onboard insight would give you the vessel's captain to decide how he want to proceed further. So now we talked about and understood what is edge compute is all about. So let's see how difficult or what are the challenges with respect to monitoring these edge computes. So basically you will have the edge servers sending some data to the cloud, especially for data warehousing, or maybe you're running AI ML analytics out of it and generating certain insight from it. So for which you need to send the data. So that means you will have to stream the data, which has to be, you need to be very efficient on how well you send the data. So now coming to the observability, unlike any other cloud services where the network connection and the bandwidth is not a challenge, whereas in edge, it's always the biggest problem. So now coming to the edge, there are also other problems, like you have a resource constraints, because these onboard edge device could be a small, simple Raspberry Pi, or it could be an actual edge compute device, say with the 8 GB or 32 GB, 8 CPU and 32 gig memory. But it needs a lot of CPU and compute capacity basically to process the sensor data coming at its way. So that means when you're deploying an observability solution or an agent on an edge machine, it is always a big challenge. Now, it is also a big headache is that intermittent connectivity. So if you have, there are certain edge farms, locations, say like solar plants or wind farms, where the connectivity would not be a problem. But imagine you have an IoT device. For example, you may have a refrigerated truck which is shipping some perishable item. Or it could be a big, large vessel which may be in the middle of the sea, where connectivity is a big question. So, and also the connection which these kind of ships uses is actually a satellite network. Even the bandwidth of this satellite network is very limited. It will be in KBs, right? It kind of takes us to the old school, where we used to have this DSL router which was giving us the bandwidth in KBs. Now, again, you have high volume of data, and you need to send some of the sensor data to the cloud all the time, where you will not have much bandwidth to send your metrics and logs into the cloud. So you have to be really efficient, careful what you're sending it from edge to cloud, especially on monitoring or observability perspective. Now again, coming to the problem of security, there are all certain challenges when you're deploying and configuring the observability. You have to be a little careful on how securely you're transporting or shipping the data, especially metrics or logs, from your edge device to cloud, because there could also a situation that somebody can peek into it. And most of all, when you offer this as a SaaS product, you need to maintain the multi-tenancy and even keep the data in different storage locations, not even just one storage account. We're talking about separate storage accounts may be situated in different places. So how did we solve this problem? So even before we come to this, right, why are we explaining all this? So basically our journey started where the edge platform, which was already there, was running on Docker containers, and we decided to modernize it to Kubernetes cluster. And this is where we opted for K3s as the lightweight Kubernetes to run on our edge, where we have installed it. It could be a single node or a multi-node cluster. And we used centralized AKS cluster to process the data, where the data is being processed, and also our observability platform was running on another cluster. So we built all the observability solution around the open source toolings, and we used onboard Prometheus to collect the metrics and ship them to the Thanos. And we also used Loki on board in the edge as well, and also we have a distributed Loki in the cloud. And we used a lightweight agent called as FluentBit, which was streaming the log. And for security requirement, we used Falco, which is an intrusion detection product. And also we used OAuth2 proxy to validate. And also we have used Keycloak to generate the JWT token when you are sending the metrics and logs to the cloud. So let's discuss some of the key challenges in metrics collection. So one of the key challenges is that your application is generating some custom metrics, and they may want to actually collect this in an interval of, say, 30 seconds. And in terms of the regular metrics of system and Kubernetes, we would want to collect the metrics in 30 seconds, but sending that to cloud is the biggest luxury. So it is not possible. So you do not want to extend the interval where if you start collecting the metrics every 5 minutes, you're losing the key measurements or the change in measurement. So this is where we had to actually look out an option how we can actually collect all the metrics, yet we send only the required metrics in an efficient and better way, where we get all the insight, yet we are not really rocking the bandwidth. And also, onboard Prometheus, we have noticed that Prometheus takes about minimum of 500 MB of memory in onboard edge, which is kind of a luxury because if you add more workloads into the Prometheus, just the plain K3s with the Prometheus was using about 500 MB of memory. So we had to fine tune that as well. And later, we also had a problem with network bandwidth. As I said, the satellite networks are very expensive in terms of transmission, as well as the bandwidth is also very less. We had to think about a way how to take care of it. And also, when you have thousands of edge, which you are sending the data from, you have to be really careful about the cardinality issue as well. And there was always a big question, how do we use push or pull based metrics? Like, do you want to push all the time, or should we pull the metrics when you want it? And also, how do you data aggregate and generate some insight out of it? So how did we solve it? So we used Kubernetes stack at edge. We were collecting the metrics every 1 minute, and we were collecting custom metrics based on the requirement of the application. And we were also using relabeling, trying to minimize the labels. And also, we started using Prometheus rules, which was able to get certain insight. We were only streaming selected metrics. We also ran into a problem where streaming the metrics with the help of Prometheus remote write was not an option. Because of the number of labels that you have in every measurement, the entire bandwidth it was consuming was high. So we came up with a custom solution where we gave a unique identification to each metric sample with the labels, where that data, which is basically the identifier and the measurement, is passed on to the remote Kafka queue or event hub. And it has been read back in the cloud side called as metric receiver, which was kind of cataloging all the metric names and labels, and it is generating this unique identifier and handing it off to the onboard Prometheus. So it was able to reduce the amount of ingest significantly with the help of this. Again, if you have a fixed connection, say like solar farm or wind farm, it is not necessary that you have to use this. You could actually straight away do a remote write. Now coming to the Prometheus, I will explain on the cloud side, we have used Thanos. We'll talk about multi-tenancy slightly after. But Thanos also has a capability of something called a sidecar, which you can run it on the cloud side Kubernetes cluster. As I said earlier, we have the data warehouse where it is running on the Kubernetes, where we will also be monitoring this cloud Prometheus with the help of Thanos sidecar, where we are not ingesting the data from this Prometheus to Thanos. Rather, whenever a query is happening, it is going and fetching the data from the Prometheus directly on the cloud. Because over there, you don't have to worry about the cloud network connectivity and other issues. So, and also, since we had a requirement to store the data for quite a long time, we started using the option of downsampling, which kind of helps us to aggregate the data and downsample that for, like, say, 5-minute aggregate or 1-hour aggregate, etc., which also helped us significantly reduce the amount of metrics and measurements which you are storing at our cloud side. So now I'll pass on the mic to Mr. Karthik. He will walk you through some of the key challenges we faced in log collection and how did we overcome that.
Hi guys, thank you Naveen. Now we have what metrics. So we have the metrics here, you know what is happening with your application, but you know there's something wrong with your application, but still you don't know why factor. So that's where the logging will come into picture. So you need to debug in the logs and see why your application is crashing. But there is a slight problem with this logging mechanism. So one would be the high volume and velocity that you have with the platform that you have. So be it container logs or OS logs or your application logs, you are bombarded with logs, and the volume that you're getting, if you start sending all these logs, then again your network bandwidth will be out of range. So you don't have the luxury of sending all the logs, and you don't necessarily need to send all the logs. So one problem is volume and velocity, and then we have intermittent connections. So if you start sending all the logs and if you don't have a retry mechanism or something, and you'll start losing the important information. And then let's say we decide to store locally, but we can't do that too because we are running it in edge and we have limited space. And if we start storing all the logs, it kind of it takes up all the local storage that you have, and you need to have a proper mechanism to clean up this. And then you have parsing and standardization. So since we have a different edge systems, there your logs can be kind of structured or unstructured logs. So you need to standardize it and pass it properly before ingesting it. And then we have security and privacy concerns too. Because in your log, you might have a user data, so that might need to be encrypted before you send it out. And then we have query efficiency. So if we just push all the logs to the cloud, you have to also make a mechanism to actually query it efficiently. So we need to structure and label the logs properly. So let's see how we handled it in our case. In the edge side, we have FluentBit, which basically acts as a log parser. And we have enabled a retry mechanism. We have written retry mechanism in the FluentBit. FluentBit is nothing but a lightweight version of your FluentD. So that can be deployed easily on your edge boxes. And then we have Loki, onboard Loki, so where we are streaming all the logs. And also said you guys, we are not shipping all the logs. We don't need to ship all the logs. So we are only shipping the selected audit logs that are actually required to our Loki, and from Loki to our cloud Loki that we have. But we are also shipping this audit logs, passing this audit logs to Falco, which is our real-time onboard intrusion detection system that we have. And we have written a custom Falco rules that alerts us depending upon the scenario, like if someone tries to access your containers, if a malicious actor tries to access your container, or someone tries to open a shell prompt, it will actually alert us on that. And we are also streaming this alert into our cloud platform. So coming into the cloud end, we have FluentD, which is a highly available, highly scalable log parsing platform. And in FluentD, we are actually collecting all the logs from the edge system, and we are passing it, and we are relabeling it, and we are optimizing the log, and we are sending it out to Loki. And Loki, it's a highly scalable Loki. It's a distributed Loki that we have in the cloud.
One more thing to add, you may notice that we also have this auto proxy and key clock. We'll explain that shortly. Okay?
Yeah.
We are all validating all the data which is sending into cloud. So this is where we kind of made a little customization where all the ingest is getting validated with that.
Yeah, thanks, Naveen, for that. So yeah, now comes the security requirements in Edge. So first and foremost is we have to encrypt all the data which is at rest and also during the transit, and we need to authenticate and authorize the request, and we need to have a real-time threat detection, and we also need to have auditability. So how did we tackle all the security requirements? For the intrusion detection, as I already mentioned, we have Falco, and for audit logging, we are selectively getting the audit logs from FluentBit and streaming it to Loki, and in the cloud end, we are sending it to Azure Sentinel. So that becomes our security incident in the cloud. So then encryption at rest, we have Lux. We use Lux mechanism for encrypting data at rest, and also in cloud, we use SSC, S3, or KMS encryption model. And encryption in transit, we use TLR-SSL protocols. And in VPN tunnels, we have our GSN network, which take care of tunneling the traffic. And coming to authentication and authorization. So we had a problem in Thanos and Loki. It doesn't come with a built-in mechanism to validate your request, or it doesn't have a mechanism to know who is actually sending the request or validate that request. So that's where we used OAuth2 proxy. So basically, OAuth2 proxy sits in between our API in the cloud called to our Loki and Thanos, and it actually validates the request. And we are passing the client ID and client secret, which are generated from the key clock to generate the JWT token, which will showcase in few slides from now. And we use key clock to authorize the request and to maintain the fine-grained access. So with this, I would give multi-tenancy to.
Yeah, so just to highlight, this OAuth2 proxy, what we are using is for the ingest. We have a different mechanism when you are actually querying the data by that. So yeah, so here is the multi-tenancy what we have achieved. So we will have certain times with the requirement that, customer will come and say that I need to store the data separately. I need to have that isolation. And also we had to maintain that certain times if they ask us that, okay, get rid of my data or forget me, I have to have a flexibility of taking care of that. So this is where what we did is we leveraged the Thanos hash string concept in the receive. So what happens is that when we are sending the data, so for the multi-tenancy, we had a requirement that we had to separate the storage, where we wanted to either go with the shared storage for certain requirement, and for some of the requirement, we had to have the hard isolation, where we had to have a dedicated storage for it. So apart from that, we had a requirement where one of the customer asked, I would like to see that metrics too. So that means you need to make sure that your data is accessible, whatever you are sharing as an endpoint or some means, through which only that specific customer's data is visible. So in order to do that, what we have done is, we have actually done the remote write from the onboard Prometheus, through which you will be able to send the data. As I said, we had two different kind of options. When you have an intermittent connection where the network bandwidth is low, we built our own solution. And we kind of come across as an option where Prometheus gRPC Pro 2, with the help of that, we were able to process these messages in the cloud and push it directly without using any intermediate platforms. But if you have a fixed edge where you have a network connectivity is good, you could actually straight away do a remote write where you can authenticate with the help of JWT token from the key clock, and it will actually send the data along with the XOR header or the tenant ID in terms of Thanos. So here what happens is, when the data is sent from any tenant's edge, it reaches to the Thanos receive. And Thanos receive, we basically have one primary Thanos and tenant-wise Thanos. They are all been put together or integrated. So all the traffic goes to the primary Thanos receive. The primary Thanos receive will have the hash string. The hash string decides which receive service shall take care of this request. So based on that, if it is a tenant A and B, then I'll be sending it to a specific storage account in the backend. Likewise, even for tenant C, I will do it for something. And it is also possible that you could also have a soft tenant. Like if I have not defined the tenant, so I will also give a default tenant in which the metric had to be stored. Now, that also means I need to maintain separate store gateways. Basically, store gateway is the service which interacts with the backend storage to fetch the data when you're querying. So that means I also have to integrate that together into the Thanos query, so that whenever I'm querying, even if I have multi-tenant, it should be able to pull the data across different tenants. So this is how we have achieved it. I will show that slightly after. So here is the example I was talking about, the hash string. If you see it onto the left, so here you can see that I've written a hash string. If the hash string name is Milky Way, if the tenant name is or Milky Way, or which is by the way our Milky Way or Meteor, it will be taken care of by the tenant called as Thanos Milky Way. If it is Andromeda Galaxy, then if any tenant named Andromeda, it will take care of that and send it to a separate storage account. And if it is not, we have a default one, which is our primary Thanos, which will be handling the traffic. So when you ingest the data, this is how you will be seeing it. So you see that there are 3 receives, which are different for different tenants. One we have as a default, which is in the middle. I also have something called as tenant ID as test, which is basically I just sent a data without it is neither Milky Way nor Andromeda or Meteor. So the same way, you will also see the store gateway, where it will show you that which tenant's data is stored in appropriate store gateway. So this is how you could actually set up the Thanos query, where you will have multiple tenant data is being pulled from different storage accounts. So let's have a quick walkthrough of what we have done. So we have done everything in cloud with the help of Argo CD. So we are using app of apps where we have deployed. And here is our Thanos, which is our primary Thanos, if you can go back a little bit. So here is where you can see that you have Thanos Andromeda, Milky Way, and the primary Thanos. Yeah. So now if you notice this, so this is our Thanos deployment, where you have all the services, including the Thanos query, Thanos receiver, which is basically taking care of your ingest, and Thanos query is basically you're retrieving it from it. And now you may notice that you also have this Thanos Andromeda and Milky Way. So this is how we are deploying it declaratively. and configuring it. And hashing is something we deploy it as a config map and use it in our primary Thanos to read that. Now we are using Keycloak for authentication. I'm using over2 proxy as the client in the ingest end, which is associated with my ingress definition, where every traffic going through that ingress definition get validated. So here is where I'm defining the token URL and also the credentials. Along with that, the Thanos tenant ID is mentioned, which is Andromeda. You may notice there, yeah. And also the edge name, I'm mentioning it as Nebula, which is one of the planet in Andromeda. I'm just using galaxy name just to make it simple, you know. Yeah. So here is how you can see that I'm actually querying the data in the Thanos query, where you will see all the tenants' data is being listed. You can see that you have Andromeda, you have the Milky Way, and also the test tenant. And here is where you can see that I'm just fetching. By the way, it is in Thanos, all the tenant names gets into as actually another label. So which is whatever the tenant name that you're passing becomes tenant underscore ID's value. So the advantage of that is that you can make dashboards, the unified dashboards, where you can toggle between customers and you will have the common operational dashboards. You can just simply use a different tenant name, the edge names, from which you'll be able to see the metrics and measurements. So here is how I have actually deployed it to the Flux with the help of Flux CD to the edge. We have used Flux CD, although we had our own custom solution. What I would recommend for edge solution is that Flux CD, because it is a push-based GitOps, whereas the Argo CD is more of a pull-based, where Argo CD is repo server is polling the repo, and sometimes it is not possible, and the bandwidth which it is taking to poll the data is actually high. That's why on demand basis, we can invoke it with the help of Flux CD. So even we have deployed all our edges just for this demo with the help of Flux CD, by the way. Everything is bootstrapped with that. So here is the hash ring I was talking about, where I'm actually passing it. So when you query the data, let's say if it is all tenants, you will see all the tenant IDs here. And let's say if you want to have a dedicated endpoint for, say, Andromeda or Milky Way, you can enable the Thanos query front end for it and make that entirely completely isolated, which others would not be able to even hack it, or you will not run into any vulnerabilities. Yeah, so here are some things what we can explain. So what worked for us is that you have to start small, and you need to do it well, and also try to automate everything. See, unfortunately, when you deploy to edge location, say if it is a ship, it is not possible to even go back and fix things. So you have to be really reliable, and you have to make it automate everything, and use labels extensively to organize the data measurements, like you classify and easily, uniquely, and look up the data as you want. Use lightweight agents, like you can use Fluent Bit for metric collection, or even Grafana Alloy, and design it for resilient, look out for all the failures that you would have, and design it also in terms of security at mind, and also develop centralized dashboards for these, and set up proactive monitoring, and also monitor the monitoring platforms, because you need to keep an eye out on the monitoring platform as well. So what is the key takeaway from all this is that we built a purpose-built architecture we have adapted, but we leveraged all the CNC open source tools around here, and we looked out for and designed the entire setup for resilience, and also we embedded the security so that it is also required by regulatory compliance, as well as we had to keep an eye out on our security compliance. And also, you need to build a robust observability platform, and how you actually keep an eye out on these edge boxes with the help of open source tools, because you need to be a little smart when you're sending metrics, because you will not have the luxury of sending all the metrics. With this, any questions, anything to ask? So, too confused?
Hello.
Yes.
Yeah. So with all the metrics flowing from the edge, one of the concern that's always there is, what if you don't have connectivity for a long period of time? How do you guys handle that?
So, first of all, it's a good question. Actually, we often run into a problem. The ship is offline for, say, 15 days, so you will not be able to get that. So the data gets streamed the moment the ship comes online. And this is where we had to develop our own custom solution where we can drop the older metrics. Okay, coming to the question on the logging, if you are asking, so we are selectively sending certain set of logs. And apart from that, we are also have a interface from which is log forwarder, where developer or somebody can request the logs, which will be pulled from the onboard Loki with the help of APIs. But unfortunately, we have to live with the network. But reliable transport, we have our own service which we have developed, which use protobuf and also retry mechanisms. With the help of that, it will send it. Apart from that, there is also the built-in retry mechanism and also the caching in Fluent Bit itself, which will take care of that to a good extent. Say, even if you just run a Fluent Bit, which even if you have the configuration in the newer Fluent Bit that you can remove or don't send the older logs if it is not needed. Or you can even exponentially retry as well. That is also possible. But there are certain occasions we had to reconcile, and that's where our in-house integration helped us to reconcile in some places.
Okay, got it. Is there some kind of compression?
Yes, we use protobuf to send the data from especially for log transportations. And I think Prometheus also already uses the protobuf when they actually send the data from when they do a remote write.
Okay. Yeah. Thank you.
Any other questions? Yes, I think there are some they want to ask.
So, yeah, so as you are using Prometheus, right? So I just wanted to understand, so let's say, for example, we have 5 namespaces inside our Kubernetes cluster, right? Yeah. And we want to do the filtering of 2 namespaces, right? Yes. So we just want the metrics from 2 namespaces. So if you talk about this technique, have you implemented in your setup?
So this is where I suggested Grafana Alloy. So basically your Grafana Alloy is a stripped Prometheus. So instead of running an onboard Prometheus, you could actually switch it to a Grafana Alloy where you can write rules. Even in vanilla Prometheus, right? You can use labels techniques to even selectively collect the metrics from a specific namespace. Okay, and then metric names as well, by the way. Yeah.
Okay, so we can drop it, right?
Yes, exactly. The relabel is meant for that, by the way.
Okay, thank you.
My question is that why did you only prefer K3S and not any other orchestrator?
So we were actually about to say that, it is just our choice that we went with K3S because we initially planned 3 years ago. Back then K3S made us a good choice because K0S didn't had that maturity back then. But given a choice, there are other options too. Like if you are if you are in a Red Hat ecosystem, they have the Red Hat Edge. You have K0S, you have MicroK8s. It depends on how well you maintain. Our intent was to use Rancher's server in the cloud so that it can be easily managed. Okay, it is more of a choice we made, but you can pick and choose any Kubernetes and Edge.
Okay.
So, yeah, there was one more question. I'm sorry, what was that?
Depends.
So we are actually retaining it for 15 days. I think the single node cluster, right? So it was using somewhere around 8 GB because we didn't had problems with the storage because there used to be a RAID storage which used to take care of it. Only challenge we had was actually the memory and CPU because it's a big challenge. You have a 8 CPU and 32 gig memory. And certain there were edge clustered K3s we ran, where even tiny MLs were executed, where they were getting some ML analytics out of it. So the application will take the precedence in terms of compute usage. And that's where the biggest pressure for us was to reduce the computation capacity.
Hello.
Yes.
Yeah. So when you're already running on an edge where you have resource constraint, why would you choose Prometheus over Prometheus agent, which is much more lightweight?
I'm sorry, what was that?
Why would you choose Prometheus over Prometheus agent, which is much more lightweight?
Yes. So we had to have a Prometheus because we already had a solution, because it's not just K3s we were collecting metrics of, we are also collecting some other metrics as well. And also the retention was very important to us, because even there are situations we had to go back and run the PromQLs to fetch the data from the onboard Prometheus as well for finer intervals. Like you want to get a better interval, or certain metrics are not being streamed to cloud. Whenever you want to investigate, you will connect and pull the data from there.
GSN network,
Yeah.
which will take care of that.
Thank
But
you.
it's a good option. As I said, if you have a very good connection, you can straight away go for Grafana agent, Grafana Alloy.
So my question is related to how you manage your edge machines, because there is the internet networking issues will be there. In that case, we cannot do anything, right?
Correct.
But your edge machines setup is also complex, right?
Yes.
So there can be issues with the K3s, there can be issues with the Prometheus. So
Yes.
how do you monitor that? It is a network issue, or it is actually your edge machine is down, right?
So we have, this edge platform, we had it from quite some time. We modernized it from regular Docker container to K3s. To answer to your question, the deployment, we had our own in-house deployment solution agent which was doing it. In fact, you also run into a situation that how do you cache the images in the edge, because you will not have network bandwidth. You can't push a bigger containers and all that.
Yeah.
You have
That
to
was
kind
also
of...
a question. Are you using the air gap, or it is
we had our own,
branches,
like I
right?
said, protobuf based solution, which was also transporting the data to the cloud as well. And there are edges which we have not touched it for almost a year and still running. In order to keep an eye out on them, as I said, monitor the monitoring. So you need to keep an eye out to see is there anything wrong. And also we had custom metrics. We were collecting metrics of how our sensors are behaving, how much data we are collecting, and also the data quality of like how much data the sensors have sent, how much we have received in the cloud. All of this will be measured in order to verify that everything is intact.
And we also have a platform where we deploy our updates whenever the ship comes online.
Yeah, we also upgrade the K3s in the same fashion, where we have an agent which pushes all the binaries and goes and executes the upgrades for us. And there was a complex scenario we ran into, was actually upgrading a single node cluster to a multi-node cluster, where you had to change a lot of things. It was a big challenge, but we had addressed it too, in case if you're wondering. Yeah, any other questions?
Yeah, so in this advanced filtering, how you guys make in that aspect of irrelevant or relevant data, basically?
Sorry?
So how you guys recognize, okay, is this a irrelevant or relevant data to be in advanced filtering?
Oh, you mean to say how you decide which data to send to cloud, right? So which is basically by business you would understand, right? See, certain regulatory requirements want you to send the audit logs for sure. Even in audit log, there are different types of audit logs, right? You don't want to send a payload certain times. You don't want to send all the data, but you still want to store it somewhere. That's where we keep that in onboard low-key. But we only selectively handpick them and send them to the cloud. And also that's why we have a onboard low-key, which is, Falco, which is aggregating and alerting it us in case if there is something which we have missed. And coming to the application perspective, we don't pull the data unless otherwise the business demands for it. Typically, you look for application logs if and only if you have a problem, right? So that's when we have your log forwarder, which actually goes and pulls the data for that.
Yeah, because like in troubleshooting, you for sure need that data.
Correct. Yes.
Any other questions? think we are good.
Yes. Yeah, in case if you have any further questions, feel free to connect with us. We'll be happy to address them. Okay. Thank you.